All right, good afternoon, everyone. Welcome and happy Friday. Uh, let's see here. Let me put these chats somewhere where I can see them and tuck the OBS window away. Off. Hit the button there. Looks like we are showing green there. All right, good to go. All right. All right, yes, welcome, happy Friday. This is the Deep Dive, which is a weekly live stream program, and if you are new, if you've never watched this before, my name is Tim. I go by Foamy Guy on GitHub and Discord, and this is a stream that occurs every week on Friday at this time, working on CircuitPython stuff. It is, however, most typically, the person on the stream is not me. It's actually usually Scott, the lead developer of CircuitPython. But he is out this week. He was out last week as well, so a couple weeks. He's got some other stuff going on Friday, so I am here. And I usually fill in when he is gone, if I can. So that's why I'm here. Thanks to everyone for watching. If you are new and you don't know what CircuitPython is, you can learn more about that at the main website for the project, circuitpython.org. This is basically a version of Python that is designed to run on tiny computers called microcontrollers. Today we'll be looking at some Bluetooth ones of these. Bluefruit Sense, is that going to come up? Yeah. I've got a couple of different Bluetooth ones. One of them is this Feather Bluefruit Sense. We've got some more, but before we jump right in, let's finish the kind of intro, so to speak. So CircuitPython runs on these tiny computers, like the Bluefruit one that I just had pulled up there. And it allows you to plug these devices into your computer. They'll typically show up like a thumb drive. You can then edit a Python code file on that thumb drive and save it. And then the tiny computer that's actually on this little board here will recognize that new Python code file and interpret it and execute it for you. So that's kind of the high level view of what we're doing. That's what ties everything together here. Scott, like I said, is the lead developer. So when he does the stream, he's usually working on cutting edge stuff. Whatever is upcoming in CircuitPython is what he's working on by definition. I do not usually go quite as deep, so we go to slightly shallower waters for the deep dive. And in particular, this week we'll be working on the BLE workflow again, trying to work on the integration with BLE workflow and transferring files back and forth, listing files that are on the device, that sort of stuff. If you are interested in this topic, you can catch last week's stream where I was figuring out some of what we will work on today. I've made a little bit of progress since then, and then we'll do some more work on that today as well. How's it going, Tyth? Excited to read that you got the breakthrough on BLE file transfers. Yes, I have. I've gotten further than we were last week, and I actually kind of know at this point, the light at the end of the tunnel, so to speak. I kind of have an idea of how to do the rest. There is still some things that I don't know, which would be nice to figure out in the end, but I have enough that I think I could actually finish the implementation. So now it's just kind of sitting down and spitting out the code to do it. Let me also, before we jump in, let's say thanks to Adafruit as always. Adafruit is a hardware and software company based out of New York. They are the ones who make CircuitPython possible by paying the folks who work on it. Scott, who's here most weeks, is one of a number of people who are paid full-time to work on the CircuitPython project, and there are some folks like me who are paid to work on the project part-time, and Adafruit is the one doing that. So huge thank you, as always, to Adafruit, and if you would like to help support CircuitPython and Adafruit, one of the easiest ways you can do that is just heading over to their website, adafruit.com, and purchasing hardware. They manufacture and design all sorts of little hardware devices. The microcontrollers themselves, like the ones that I am working on today, are Adafruit devices, but they also have all sorts of other sort of add-on accessories and things where you can hook up to your microcontroller to interact with other different electronical bits. So head over there, get yourself some toys, and thank you to everyone who does shop at adafruit.com, because of course you are helping them keep everything moving, which is helping CircuitPython keep everything moving. How's it going? Love the factory. Olaf from the Colorado. Nice to see you, my friend. Coffee cheers if anyone's got the old afternoon coffee going on. Okay, so where I left off last week, I was not getting a successful transfer. We mucked around a little bit. We were able to get connected, which was more than I had done before. And we were starting to try to do the lister, and I think I had Wireshark pulled up maybe, and we were looking at some traffic back and forth, figuring out some things. And I was trying to make this library work, BLE file transfer. This is a library that can go on a CircuitPython microcontroller, and it interacts with the BLE workflow in order to manage those files that are on some other device, right? Like this goes on the client device, BLE workflow is running on the server device, and then this will connect up to it, and it can manage the files on the other device. We were trying to get this one working, and I was having some trouble using Blinka BLE.io. Blinka BLE.io. For anybody that doesn't know, Blinka is Blinka is the snake mascot for CircuitPython, but Blinka the library, Blinka the Python module, Adafruit Blinka is a CircuitPython compatibility layer that allows you to use CircuitPython code in some other contexts. In particular, it's really meant for single board computers like Raspberry Pis and other similar devices, and then also micro Python devices, which are not running CircuitPython specifically, but are running MicroPython. But if you want to use a CircuitPython library on that MicroPython device, Blinka can help you do that. So it's a compatibility layer that allows that to work. And then in particular, BLE.io, as the name would suggest, that is the BLE module for Adafruit Blinka. So if you were on a Raspberry Pi, using Adafruit Blinka BLE.io would allow you then to use Adafruit CircuitPython BLE as well as Adafruit CircuitPython BLE file transfer. So I know we're blasting out a lot of different libraries, a lot of different stuff. Again, this is all basically last week. So if you want to go more in depth on anything I've talked about so far, last week is the stream to watch. And then to show you where I am at right now, I will jump back over to BLE file workspace here. So I have, you can see the remnants of it in my console down here. I do have a successful lister working out. This one is, though, skipping the library. This is not using this BLE file transfer library. This is not using Blinka BLE.io. Instead, this is just using directly the Bleak module, Python Bleak, which is what Blinka BLE.io uses. This makes use of Bleak internally. But the code that I ended up getting this to actually work on, for now at least, is just direct to Bleak. So no Blinka BLE, no Blinka BLE.io. However, one thing I do think I would like to do is, even if we don't use the actual full library, one thing that would be nice are the constants. Where can we grab those? So those are in the file transfer service. Maybe we just copy paste them. I think I'm going to just copy paste them. All of these will be helpful. So if you want to see the code that ended up working, we'll skip to the bottom first. So there's loads of commented out stuff. You can excuse the mess in this file. Basically what ended up working is starting in main, let's wrap my head back around this here for myself as well. So we create a client, we pair the client, we are getting a result from that, but we're just ignoring it. We then call start notify. So this is a new thing. I don't think that I had messed with this last week on the stream. Start notify is basically like registering a callback. So we're saying whenever this workflow transfer UUID, that's a characteristic UUID, I'm pretty sure. Whenever this characteristic has new data, we want it to call this handler for us. So start notify is gonna, let the Bluetooth module know whenever this characteristic has data, it needs to call this handler for us, callback handler, which that should just be a function right here, which we've defined, callback handler, and then it's going to have the actual data that was received get passed into it here, so we can then do stuff with that data. We'll take a look in the handler for just a minute, or in just a minute rather, but let's do down here first. So the next thing, so we register our callback, then we create the, this is the command that is asking the BLE workflow to list dir, that 50 right there, 0x50, that is the command constant for list dir, which we could now use instead of this. I don't know what the 1 is. The 1 is maybe, I don't know what the 1 is. That might be a size or something. Lister, yeah, we should only have 1 byte, I guess. So I'm not sure if that's size or what, but that's there. And then we just go ahead and we write the encoded message, but we also add on to it the path that we want to list. So right now I'm just listing the root path. So we have just slash, and we do need to get that into UTF-8 by encoding instead of regular string or whatever. We encode that, we add it on, that's what we write, and then when we write that, it causes the server, the BLE workflow on the other side, to actually send a response or whatever in this characteristic, which then lets our callback handler get a callback. And then what we do inside there is I have a check for if data is not equal to received data. So one thing I found is that I was getting duplicated callbacks. How's it going, Beata, over on YouTube? YouTube chat's cut off. Let me try to fix that. Thanks for the heads up, by the way. Oop, okay, hold on. That's going to be slightly tricky because moving it obscures it. Okay. Oh. Huh. All right, that is not going to be a quick or easy fix, and I'm not going to mess with it just because it's off the path of what I'm trying to do. But yeah, it totally is cutting off the bottom one on YouTube. I need to try to fix that, but I don't want to mess with OBS while we're on the hot seat, so to speak. Hopefully there's something I can apply to Linux. Hopefully this is something I can apply to Linux. Yeah, so this will ultimately, so yeah, let me also, I guess, say where I'm intending to use this. So right now, my goal for this is trying to add this functionality to circup, and then, you know, sort of connected to circup at this point is this WW shell file management utility. WW shell stands for wireless workflow shell. So this is another command line utility that is potentially going to be bundled along with circup, which allows basic, you know, getting files from the device, putting files onto the device, listing the files on the device. It's kind of like a very basic command line file utility for CircuitPython devices. Currently it supports web workflow, but this work I'm doing on BLE here, my aim is to make that utility support BLE workflow as well. And in doing so, we will basically by default end up making circup rather also support BLE, which will be cool because that's something that circup does not have today. All right, so when we receive this callback, the first thing I'm doing is checking to see if the incoming data is equal to this variable that's called received data. The reason I did this is because I was getting duplicated callbacks. So every time that I would ask the device to list dir, I would get back, you know, 2 of the first response, 2 of the second response, 2 of the third response, whatever. Just like every single message, it seemed like was duplicated. I'm not sure if I messed it up somehow in the way I asked for it or what, but the way that I got around it for now is I just have this global variable receive data, We set that equal to data, and then we just check. We say, hey, you know, is the data we just received right now the same as the data we received last time? If so, then we're going to ignore it basically by having this if statement that doesn't have an else. If the data are different, then we know it's not a duplicate, so we actually go inside of here and we do some stuff with it. The stuff we do is set our received data so that next time we can compare and skip the duplicate. We have incoming data buffer, which is another global variable, which is just a byte array. Incoming data buffer. That is just going to hold all the data as we receive it, because the thing is that the BLE workflow can return data multiple times, all within one response. So when you ask it to listener, you might get back like 4 or 5 responses. You know, like there might be 4 or 5 callbacks to this thing, but all those callbacks actually are like one, you know, list of data, right? Like it's not that there's, you know, you're getting 4 or 5 listings. It's that those callbacks each contain one, you know, I don't know if packet is the right term, but I'm going to use it anyway. One packet of data, one like chunk of data, and then the next one will have the next chunk, and so on. So we're adding all of those into this incoming data buffer, which is going to result in us eventually having a buffer that's filled with the entire, you know, what I'm thinking of as a response to our command, the entire data that represents the lister. Then we just call success. So we call attempt parse entries. This is really where the meat of everything happens. We can see here it's going to return a success and a paths. Success is Boolean, so if success is true, then we go through the paths, we print them out. We go inside of here, attempt parse entries. And notice that that's going to pass in the incoming data buffer. And the reason why it's attempt instead of just parse entries is, remember, we're adding each response into this incoming data buffer. We might not have the whole response yet. So we have to attempt because we might fail, you know, i.e. when we only have like 1/3 of the data or whatever, then we're not going to be able to successfully parse it because we don't have all of it. So we attempt every time, and then, you know, eventually we'll have all the data and this attempt will be successful. So inside of here, we attempt. And then this code, I did basically take lots of inspiration from the code in here. Lister right here. So this logic right here, inside file transfer service, basically became the logic inside of here, really with this while loop here. But let's step through it real fast. A bunch of it's unused. I should come back and clean this up some, definitely before it gets into circuit. But let me step through it real quick just so everyone can see and so that I can wrap my head back around where we're at. So data buffer comes in. We got a couple of variables. Looks like found entries might get used. That one's starting out at 0. A couple of these are not really getting used. We do have a total that starts on 10, but will get changed whenever we get the first response, because that first response will tell us the actual total number of files we're expecting. Header size, so that's calculating how big the header is. Each response comes with a header, basically, or each file, I should say, comes with a header. So your first response is like a header, and then a file, and then, you know, you'll have another header after that, another file, header file, so on and so forth until you've gotten all the files. So that's going to actually go ahead and unpack the first header, the packet for the first header, or the header for the first packet, I should say. It's going to set them all into all these variables here using this destructuring with the tuple. Expected entries equals total. So yeah, that first response there, that first header gives us the actual total that we're expecting. So we're going to put that inside expected entries. That way we can test against that going forward. It does print out, we're expecting to find total number of entries. We then have a while loop. While find entries is less than expected entries. Here we're going to go offset plus equals header size. Encoded path equals empty string. Path read is basically going to use, what is that? That's just using length incoming minus, so path read. So this is like how many bytes were read this time around, basically. And then, or not this time around, but how many bytes are there in the entire buffer right now, basically, minusing some offsets. So we're saying if the path red is not equal to the path length, then we know we're not done. So whenever path length is going to be, whenever path red equals to path length, then we know that we've actually parsed everything. So if it's not equal, then we have not parsed everything, so we just return false empty list. After that, so remember we just grabbed our first header basically. After that, we're going to try to grab the first path. So we get our encoded path by just reading it out of the buffer using square brackets and the colon to kind of say like we want to start at offset, we want to go to offset until read length or whatever. Let's see, if the length of the encoded length is less than this length of the encoded path. So this could be like if the encoded path is split between responses. If we started the encoded path in one response, and then the packet ended, and the rest of it's actually in another packet. And in that situation, I believe this code fires. We know we're not done yet, so we just say, nope, not done, return empty list. Otherwise, though, if we do make it past those two checks, then we go ahead and just add into our paths. That's just an empty list that we're building up. We add a new tuple into that, which has the actual path, the file size, the flags, and the modification time, all of which got read out of the data that come to us, right? These all got broken out in these things here, except for encoded path, of course, which is getting built up right here. We go found entries +1. We go if we have found the maximum, if we found all the entries we're expecting, right? If we're expecting 10 and that was the 10th one, we know we're done, so we return true in paths. Otherwise, we go offset equals plus equal to the path length, and then we try to unpack the next header. And if we fail to unpack the header because we didn't have enough data, then we know that we don't have all the data, so we return false and list. And then, attempt will get called again in the future. Whenever we get another callback, we'll try again. So, kind of quick run through there, but that's what this is doing. That ended up being the way to make this work. I think I want to do another. Yeah, I think I want to do another command. So that's lister. Let's do like let's do read, like read file. So read file, we send it the command 10, we need to give it a path, and then it will return the full contents of the file. The header is 4 fixed entries and a variable length path. So the header, the first byte is the command, that's 0x10. We have 1 byte empty, that's the same as the other command as well. We have a path length, that's 16 bits, 2 bytes, a number that tells us how long the path is going to be. We have a chunk offset, 32-bit number encoding the offset into the file to start the first chunk. So I think that's like if you didn't want to read the full file, like if you wanted to read the second half of the file or something, or if you wanted to skip the first 100 characters or something, this would let you do that, I'm pretty sure. Chunk size, chunk offset, and then chunk size, that's a 32-bit number encoding the amount of data that the client can handle in the first reply. And then we have the path, UTF encoded string, it's not null terminated because we told it the length right there. It's going to write you back with answer, which is 11, empty byte. No, maybe not. I don't know if that's going to be empty. I don't think it's actually empty. I think it will have something. 2 bytes reserved for padding. There you go. There's our empty ones. There's actually 2. Then it's going to give us a chunk offset, which is the offset into this file. So we would start on 0, presumably. The total length is the length of the file in total. The chunk length of the red data up to the chunk size provided in the header. Chunk length, contents of the file starting from the current position. If chunk length is smaller than total length, then the client will request more data. Okay, so we need to actually keep going back and forth here, basically. So I'm guessing on the smallest of files we won't have to do this part, but if we get our first response and it doesn't contain the entire file, then the next thing we need to do is send it a 12 command where we would set the offset to the offset we got last time plus the chunk length, I think, that came back last time. So then the 12 command would let us read that next chunk. The number of bytes to read, it may be different from the original size. It does not need to be limited to the total size. So chunk size, it sounds like we can set it to whatever we want, really. And since we're on a PC with a fairly large amount of RAM, I'm inclined to set it to something pretty big. All right, let's give this a try. So I'm going to go bleak basic read file. So the reason I want to get another one of these done is, like, once we have 2 of these, then I could start trying to, like, actually refactor it into one thing that's kind of able to call different commands and accept different responses and stuff. Right now, this is very much only going to parse the response to the listdir command, right? So some of this can be the same. The way this buffer works, I'm pretty sure should be the same. But this part will need to be different. I guess, I don't know if I ever ran it. Let me, I know we walked through all the code, but let me go ahead and run it. We might need to do the old new one you saw last week. I had to do this a bunch. Go back and forth action there. Yep. See, it succeeds after that. I don't know what's up with that, but that's a thing. For whatever reason, for me, I need to do that back and forth thing to kind of just like jog my BLE adapter, I guess. I don't know. Maybe there's some kind of code I could put in here to do that, I'm sure, but I don't know what it is. Maybe just a scan or something. Oh, I think this is doing a scan, though. Maybe it's not. Yeah, I guess it's not, actually. Well, get address. Just set as a variable. Okay, yeah, it's not doing a scan. Maybe I need to just do a scan from this. That's one thing we could try. Okay, I am also gonna delete a bunch of this stuff because this is all specific to listdir. Obviously, all this is all specific to listdir. We could keep this because we might have a similar thing there where we need to attempt to parse the file, and then you know, if we're not done yet, we need to like send another thing. You know, that's weird that you have to send. It's weird that you have to send 12. Kind of, to me at least, because with listdir, you send it one command asking to get the list of the directories, and then it gives you n responses. You get multiple responses back. Whereas, and you don't ask for the extra responses, right? You just ask once, and then you have to keep listening, and you just get multiple responses. Whereas this, it's like conversation. You ask for one, you get a response, you ask for another chunk, you know, then you get another response. But, you know, it is weird. Like, this has an offset already. Like, couldn't you just, whenever you received an 11, if you were not done, couldn't you just send another 10? Like, what's the difference really between 10 and 12? Because like they're both effectively just asking for a chunk out of a file at a given offset. No path, that's the difference. So with 10, you have to send it the path. With 12, it must just keep track of the one that it's on. Yeah, okay. Okay. Interesting. It is still odd though that like the lister one, it just responds multiple times. It seems like this could, but I'm sure there's a reason why it doesn't. Okay, to start with, let's just say attempt parse file inc data buffer. And I think we will just most immediately I think we just print it out. Okay. So we need to add some more stuff into this. We need to add the okay, yeah, this one right here. I'm pretty sure this one right here is the length of the path. Or maybe it's the blank one. There is a blank one. 1 byte reserved for padding. Okay, hold on. Before we get to read file, but if we do lib here, does this need to be 5? EXH. I don't know my pad byte. Okay, so the X. Okay, so command, so single byte lister, pad byte X, and then in our case, H is capital unsigned short, which was 2 bytes, which was the path size. So that does, if we were doing lib, that would need to be 5 instead of 1. And realistically, the best way to do this would be to make that into a variable and then get the length of it. But let's see if this works. We need to do the back and forth. It's too slow on it. Okay. Yeah. All right. So we have 2 paddings on the end command, yes, or no, just 1 padding. 2 paddings in the unpack, 1 padding in the pack. Okay. Need to figure out how to get this a bigger playlist or something. All right. So the start of this will basically be the same. Assume that's read file. And I'm gonna go with, I am gonna go ahead and break it out now. So let's say, to start with, I'm gonna read the boot out file. File name, file path, boot out.txt. And I'm just gonna encode it here. And then we should be able to just say length of that, right? Okay, and then we need more stuff though. We need a chunk size, a chunk offset, and a chunk size. And those are both 32 bits, not 16. So I'm guessing that should be capital I, unsigned int. Zeros to start with, chunk offset. Yeah, let's do 0 for the offset. And chunk size. Okay, this one we wouldn't want 0 actually. 32-bit number encoding the amount of data that the client can handle. So 32-bit number, the amount of data, is it in bytes or what? So how big is an actual boot out file? It's pretty small. 148 bytes. Let's just try 1024. Not sure what's a reasonable value to put for that. All right, and then the path is going to get added to that as well. So I'm actually going to call this encoded command, cmd command. That's going to be this, and then the path, I think we do not. I don't think we need the leading slash. I think that's just going to be file path, but we'll see. We might actually need the leading slash. Okay. So that should send the read file command. The callback handler should add to the incoming data buffer, and the attempt parse should just print the incoming data buffer. Okay, device with address not found, so I'm just going to back and forth in the settings over there for Bluetooth. Okay. Inside attempt to parse file. One thing I notice is we... I wonder how it knew to stay connected last time. I mean, this doesn't feel like enough bytes, right? I guess let's start decoding that. So realistically, we should have one level of code that should check the first byte and then call a more specific parse. So like really we should probably have like attempt parse, which will check the first byte, and then if it is, in this case 11, it will then say attempt parse file. But I think that will make sense more when we start combining multiples of these together to do that. Hey Tim, just curious, what coding font are you using? Good question. I don't know. Whatever. I think it's the default font in iCharm. JetBrains Mono, which I do believe is the default. I mean, maybe we, but Buddha, is that 140 something files? Okay, let's go ahead and try parsing it. So we know the first one is going to be, We're gonna do like an unpack thing like we did here. We did not receive multiple callbacks, at least so far. So we want something kind of like this. But it's going to be command, and then status, and then 2 bytes reserved for padding. So byte, and then status, and then XX for 2 paddings, and then chunk offset is the same as that, which was a capital I. So pad, capital I, capital I, capital I. 1, 2, 3. Chunk length. What? Why does that say chunk length? Chunk length is a 32-bit number. And that says chunk length contents of the file. I think that's supposed to be chunk data, right? Or chunk file or something? Chunk content? Okay. So let's do only up to there because this one has a variable size, right? We have to properly handle this one before we know something about that one. I'm not sure. Let's just do those first 3. Offset, offset 0 for now, I guess. Okay, and then these are wrong. So command status, those are fine. Path length, no, we don't have that. We have chunk offset, total length, chunk length. Chunk offset, total length. Chunk length. Could have 5, 2 bytes, and 3 numbers. I don't like the way that I don't really like this destructuring pattern thing, honestly, because it makes it hard to just print these. Whoa, it makes it hard to just print these. Do this whole thing. Let's break them out, I guess. Do the back and forth click. Probably too slow now. I should probably try adding a scan or something, or a wake up, or there's something we could add to the code to do that. Okay, so we got this. We got a well, that print. So let's go hex on these, I guess. That printed the that converted to decimal. Those ones would not be. Let's just do the bytes only that way. All right, so status single byte. We got a status of 2. Doesn't say if that's Status bytes are 1 for okay, 2 for error. Got an error. So maybe we do need that slash. Is there any way to like see what the error was? I'll use other than 1 or errors. 0 shouldn't be used, but it's still an error. 5 is an error for trying to modify read-only. I guess, I mean, it must be the path, right? Like, what the error would have to be file not found. Out.txt. Okay, let's copy paste that, make sure we got the name right. And then I will put a slash. Yeah, that didn't change. For this. Like, so if we got an error, does that mean the rest of this is like nonsense or JetBrains Mono? Yep, that's the name of the font, which is just, it's the built-in font in PyCharm. JetBrains is the company that made PyCharm, so they must have made their own font too, it seems like. Okay. Looks like we actually succeeded that time. So yeah, we need the full path with the root slash and everything. And this time we got command 11, we got status 1, which is success. We got chunk offset 0, total length 148, chunk length 148. And then we did not actually read anything else, but the bit that came next was the file. Received, which we got 2 callbacks actually, right? We did, yeah. Okay, so we definitely want to keep this mechanism where we are adding to that incoming buffer and attempting over and over until we're done. I think I like that paradigm. We need the logic for reading the file, and I'm actually going to look back in BLE file transfer. My guess is this is going to have something similar. Okay, returns the contents of the file at the given path, starting at the given offset. That takes the path. It's got a chunk size equal to 490. Interesting. So I think that's probably just trying to limit it because the microcontroller has much less RAM. We could probably get away with something pretty big on the PC, I think. Start offset, offset encoded. So then that's putting the header together. There's the path as well. We write that. Byte array, calc size. Current offset, start offset, chunk done, content length. So I think I'm going to do this similarly where from this, I'm going to return like a tuple of false, and then like if it's not done, it will be false, and then it'll just be none, I guess. If it is done, then it'll be true, and it'll be the contents. And my guess is we might, I don't know, we might not want to do this inside of the, we might want to move this to inside the while loop. Where did start offset come from? Oh. Whoa, why is this? So this is, it seems like it should be highlighting all the usages of start offset, right? But for one thing, or is it, I guess it's smart enough to go through this? Oh, I don't know. That should highlight this, right? There's no, what? When you, that is weird. That's got to be a bug, right? That can't be intended. When you're on this one, you get those two, but when you're on this one, you get this one. Maybe that is intended. They're trying to show you the value, I guess. Anyway, it'll be 0. So offset, I mean, see, the thing is, like, I don't think I want to provide the offset like that. I want to always read the full file. I know the API supports chunking and all this offsets and everything, and we have to do that for some files if they're too big, but how do we do that though? So we would have start it on 0. Okay, this is a good sign that I independently came to the same one of these. Data header size, while content length is none, or current offset is less than content length. So here it's reading. We don't actually need to read. We have incoming buffer, or what it's called data buffer inside of here. What is B? Feed into B. I don't know where that B came from. It's weird. What is B? Can't highlight that one. Wolf read into B. Oh, B is the byte array here. Okay. Okay. And then that's going to be the number of bytes it read. Does it use that? It does. So we're not going to, we don't have quite the same thing there, though. Pacing. So we are gonna, well, but it doesn't, yeah, see, this is where it's weird compared to the lister. The lister would just keep returning until we have all the data. But we need to actually ask for more data. So inside of here, we need to read up to the chunk length. Then we basically need to test if that's everything or not. So I'm thinking we probably don't want to do this yet. And instead get into here first. But what is red? Red is the number the amount of stuff it's reading. So I guess that's the length of the data buffer. Because we've already read it. It's already in data buffer. Boy, it's gonna get so squirrely too if we're like trying to write the 12 from in here, but then keep the buffer moving. I don't know if that's gonna work out so well. All right, if chunk done, unpack it. We don't have bytes, we have data buffer, or B, I mean, we don't have B, we have data buffer. Chunk end, read data, that's just this. Error, that's just printing B. We'll just say data buffer. Protocol error. Incorrect reply. Pretty sure that's a BLE file transfer thing. So for us, let's just call that a runtime error. So that's okay, we have that one. So then buff, that's doing this, that'll be data buffer. Data buffer. Chunk size. What was chunk size? 490. That was just its hard-coded value. So I used 1024 for that. Let me make an actual chunk size, though. Let's also send it like that instead. If chunk size equals 0 break, encoded. So that's getting the next one. Why is it only 2 eyes though? But I guess that's... Oh, okay, that's our... Okay, that's our 12. Okay, I see. So then that'll be read pacing. Okay. Then current offset chunk size. And that's saying self.write, but for us that's gonna have to be await.client.write. But we don't have client. So there's this underscore. Is there any chance that that is the client? And I guess let's just comment this out for now so that the rest of that can succeed. Okay. Hopefully this will be the client so that we can call write on it again. If that's not the case, I'm not sure how we're going to get a reference to the client inside there. Oh, characteristic. All right, I got to run to the restroom, so I'll be right back. BRB. Okay. So maybe the characteristic could link up to the client, but and I assume we will have a characteristic. Characteristic does not point to client. I mean, we could just make it global, but that doesn't seem the best option, probably. Sender. I guess it's worth trying to see. Okay. I don't know. I don't really know any other way to do it. Well, I don't even know how do we even make that a global, because that's inside of here. Oh, jeez. Uh, uh, I don't know. Uh, why? What? Why would that be calling self.write twice? Doesn't. No, somehow I got that duplicated. I don't think. I don't really think it's gonna work. Wait outside of async. Okay, right. So that can't work because we can't call await inside of a tempt parse file. Guess that needs to be async also. I still kind of don't think it's gonna work. Unpack. Oh. I'm gonna say maybe there's some spots where that's only returning one thing, but I don't see any. Ask exception was never retrieved. Cannot unpack non-iterable coroutine object. Maybe it didn't return anything. Was never awaited. Oh, we didn't await it. Oh. Wait, how can we await it if it returns something? Boy, we have very quickly exceeded my, remember how earlier I was like, I think I know how to do the rest of the way. We have very quickly exceeded that because I don't know the right way to structure this. The needing to write from inside the callback, I don't know how to do. Not unpack. So that's because we didn't await. But if we await, then we can't see the return. Python return value from async function. Is that a thing that can even happen? You need to return values in your run function. Okay, values equals await. Okay, so equals await. Okay, let me try a scan. Let me see if I can. No, that's BLE. Leak basic. That's just going straight to there. Can I get a bleak scan? Python bleak scan. Example. Cover. I mean, I don't even think I need to actually run the scan, probably. I mainly need to, like, I'm pretty sure this is just, like, waking up the Bluetooth radio or something. Just do this. I don't know what these are. CB. That's a terrible name for a variable. badder. macOS use badder. I don't even know what that's supposed to be. Uses address instead of UUID. I mean, it's true or false then, or is it a dictionary? Can I just do without that? What if we just do without that? 0. Doesn't find it. Turn add bool. Return advertisement? Probably return advertisement. I don't know though why. Alright, well. In doubt, give it the old backseat fortsies. Oh, I just ran the wrong thing. No. Mess it up by running the other one now. That looks like it worked. Now, it didn't have to negotiate the whole like back and forth thing, right? So we basically only got. Well, I mean, technically we got 2 responses. Technically we got 2 responses, but we never had to pass 12. we just got one response with command 11 and the size values, and then our next response contained the entire file. But if our file had been bigger than 1024 bytes, we would not be able to do that, presumably. So code.py should be bigger. Uh-oh. Oh, it actually finished, and it did not infinite loop, and it has not wrecked my computer. That's all good, honestly. Let's like write that out to a file so that I can compare it more easily. We can just say content here with I'm gonna make a directory out, open out, I was gonna try to make it be the file name, but we don't have access to the file name anymore. All right, well, we know that it's code.py because that's what I'm downloading, but let me turn off some prints. We have a whole lot of prints. It's making it actually really hard to tell what's going on. Underscore did not end up being useful. Yeah, I guess that's only at the end we can do that. Okay, yeah, I guess all of that stuff's good. That's weird. Usually it would fail with like did not find device of Mac. Break it somehow further? Don't tell me I broke it further. What did I do? I haven't even done anything. Okay. So we're back to that, I guess. Oh boy. What I didn't even all I did is add the print. Or I mean the that breaking it? Is that serious? But it's not even getting to there. We don't even we never receive a callback. How does this thing know when to stop? I don't actually know how this knows when to stop. Because it just says with client. I guess if the client got closed, is that a thing that happens or disconnected? Or what? Now we're. I took the prints out? So, Okay, one thing is, I don't have this. I don't really have paths. I don't know though, I'm kind of scared to just be deleting stuff right now. We're like suddenly just broken for some reason too. I don't understand what broke. Do this. Sometimes just having luck by having that not be in there. Okay, device not found. I don't understand. We got a successful read. Let's go back to a small one. Even though it doesn't even seem like we're getting that far. It just finishes right away. Oh boy, I have no idea what could have gone wrong. I don't even know where to go. But I turned off the file, right? I don't know. We just got completely locked out for a while there. I don't have any idea what. Like, my best guess is the BLE workflow got hung up somehow. But I don't know what caused it or really how we got back from it. I mean, obviously I went to REPL and back, but alright, let's try writing the file again. That's where we went sideways last time. Hopefully, I guess let's print it and write it. We can at least get something going here. Okay, so for one thing, we got this. Oh. We need to be not returning that yet. We need to be returning false the first time somehow. Because we got our 2 responses, but both responses returned success true. But it shouldn't have been. I don't quite follow this. Why would chunk size be 0? So we need to like if length of buff is equal to content length, total length? I called it total length. Well, the workflow called it total length. I didn't just make that up. Total length. But the code here calls it content length. Oh, we can't check the length of buff though because it's creating it to be that size. How do we know we're not done yet? So we get 2 callbacks. The first one has the header. Somehow we need to know we're not done so we can return false. I'm surprised it does return true, honestly. I don't understand why it would. Because it's getting the content length, and then it's not reading that amount, presumably, because there's no more data to read, but it's still finishing. Okay, let's try this. About to return when buff is len buff. $60 $48. Okay. We know we're done if the data buffer, the entire data buffer, if the length of that is the content length plus the header length. I'm just going to say about to return length of data buffer. That's going to say over content length plus header size, data header size. So that should be the current size of the data buffer over, well, what I think should be the total size that we expect by the time we're done. Nice. It's a beautiful thing. Okay, so we go, now we just do if the length of data buffer is equal to content length plus data header size. Then we return true, otherwise we return false and none. Okay, this time none has no decode, so we would just, so here we should just say if success. I've not been drinking my coffee. There we go. So success false, content none, blah, 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 blah. Success true, content is that. Out, CodePy. Oh, I called it CodePy and it's actually boot out. Eventually this is going to be refactored. Hopefully we won't need as many globals. Actually, I'll just set this here. Target file equals boot out text. Then down here, I'm going to say target file, globals, target file. And then when we write it, we can write it with its real name. Let's delete code since it wasn't actually CodePy anyway. Go. Boot out text. Nice. And then CodePy, which is the real test, since it should require multiple reads or whatever. We'll have to send it 12, basically. Actually, there's a lot of them. Oh no, it failed. Did not actually succeed. It finished, but it never got true. So I guess our logic is probably not good there. It worked in the case where we got the entire file in one response, but I guess not in this case. I'm surprised how many times it receives. Like when we got the entire file in one response, we just received one header, one file content. Code.py should only be 1.6K. Oh no. Back to this thing again. CodePy says it's 1.6K. I'm asking for 1024 bytes, I assume. So we should, it's like 1.6. So we should need only, like 2 or 3 responses. Alright, I'm gonna do what I did last time, and I'm really gonna hope it works. Okay, something's wrong because we're over. We read past the end. We probably read multiple copies of it or something. How did it finish that last time? I guess I didn't really look at it. Maybe it had more copies still. I thought it said success true, but I was not doing the, it's not doing the check. We stop this sooner? Okay. So doing that gets it in the broken state. So now it's in the broken state. And seemingly, to get it back out of that broken state, let me try just going to REPL. Yeah. Oh, I wanted to stop. Shoot. So this is making So yeah, fundamentally this is different, I guess. Yeah, because this buffer is content length minus start offset, which for the second, so like when we send 12, our start offset will be something. It won't be 0. Should print that stuff out, I guess. Okay. So our logic is broken. We're just sending this over and over again. I'm not really sure why we got a bunch of those sendings before we ever got like a receiving, it seems, but that's basically the deal. And so basically we did something wrong. um I don't know how to put a new line in. I really wish I knew how to term replace with new line. No, not replace the new lines. Python, PyCharm. So we're gonna have /n for both, because it doesn't work. Check the regex box. New line. Fair enough. What I'm trying to see is what happened here. So we got this added in a bunch of times, basically. Click regex button at the end of the first input. Add an extra slash in front of it. I see regex, so you could do regex for both. Try that way. Would like to. We had reg, so then that would be // to find it, and then /n to replace it. There we go. Nice. Yeah, thank you. So is that the full? Let's check if that's the full file. I'm assuming this part's fixed. I mean, this is definitely not right. What is the file we are expecting? Ends with disconnected. Okay. We start out fine. We get an extra copy of the header, and we actually get it before this comment. And then this is probably messed up. This is probably messed up because of my find and replace, actually. So, okay, we got all the way past the end, and then we also started receiving basically this chunk again. Because that's in UART server waiting. So, if we had stopped here, if we had stopped right here, assuming that this was not actually messed up, assuming that this was actually fine, and my find replace is what broke it, then when we had got to this point, everything would have actually worked, except for the fact that we had this. So I think when we, for some reason, we're adding the header, adding an extra copy of the header into the final content. But the way that this code reads here, it's creating a byte array. So buff is what we return, right? Buff is what we return. Buff will ultimately hold the contents of the file. But here, that's saying byte array content length start offset when And when our start offset is 614, then that means that the size of our buffer will be content length 1.6K minus 614, so somewhere around 1,000. Would be our chunk size, basically. Is that always going to be our chunk size, or is that a coincidence? I think that might be a coincidence, but I'm not sure. But that makes it seem like this buff is not going to hold the whole file. That's on if chunk done. Chunk done is current offset equals chunk end. I don't know. The way that this is getting its size seems suspicious to me. Because in our implementation, we're going to want this to be equal to the size of the file. In the one that's in the library, BLE file transfer, it works differently because it's not just slowly building up that data buffer already. Are we in the broken state? I don't know. Now we're in like a new and exciting broken state. We're not getting the failed to find MAC address, and we're not getting the just run and finish. I like broken it further. Oh, I need to stop. Shoot. It's not ready. How's it going, Gary T? Thanks for tuning in. I will give you a heads up, though. I am about to be wrapping it up, in fact, for the day, though. So I will say it's a good opportunity, I guess, for anyone who's interested in this sort of stuff. I'll be back tomorrow over on my own channel, streaming tomorrow morning at 10 a.m. Central Time, some more CircuitPython stuff. I'm not sure if I'll be working on BLE or not, possibly. I'm not quite decided. Kind of depends how I feel in the morning. But yeah, if you are interested in more CircuitPython coding stream content, I will be back tomorrow morning for that. And I usually put links in the live broadcast chat over on Discord here. I was lurking. Nice. Great stream as always. Yeah, appreciate it, friend. Thanks. Okay. I think the way, so that is actually always is the right size, though. So maybe that's not wrong. Maybe that's actually right. Okay, it's because it only calls that the first time. It only calls that the first, okay. Now that makes sense. That does make sense. Somehow, though, we're accidentally getting part of the header into buff. I wonder if it's the first time through we get the... Well, we know it's not the first time through, though, right? Because we looked at this file, so it's the second time. So then... went to the wrong file. It's like this suddenly looks way different now. I don't know. Let me see here. So that would be here. Data buffer read. It's got to be this right here, right? This has got to be the culprit, I think. So out offset, current offset minus start offset, and then that says buff out offset colon out offset plus read. Well, I might have messed up my read size. I did just yeah. Probably that's wrong. Probably that's wrong, which then means potentially the place inside of buffer where we start writing could be wrong, but then also the place where we start reading from, that is also wrong. Essentially. I think we would need this, instead of this being read, this should be red, I guess it's supposed to be. I don't know what it should be, I guess. It should be the amount of data we read last time plus the header, I guess is what it was, but we went and broke it by changing it to this. Oh, now we're in the we're in this broken state where we need to go here. Then do we get a fail MAC address or do we get a success? Where do, oh, I should have been stopping. How come I never remember that I want to stop until I am seeing these things scroll past? Yeah, and this time I was too slow. Looks like I don't even really have the opportunity to see the very beginning. Yeah. So after the first read right here, well, but we do have these ones. We have buff starts with our header, and then we get into here and we have buff is the beginning of our file. And this first time we read the first little bit there, and then after that we just have zeros blanking out the whole rest of the byte array. And then starting right on our second read right there, we end up starting at the location where we left off, but instead of actually putting in the correct content of the file there, we put in the header, and then it looks like it's actually just starting the whole file at the beginning again, because that's the first line. I think, right? Yeah, that's totally the first line. Then we do still have a bunch of padded out zeros. But we end up putting that header, and then we end up starting a new copy of the file. That's weird. We have not quite padded with zeros, but also not the header. I don't know. Okay, so basically the code that I stole from BLE file transfer, because of the way that it fundamentally works different, where it's actually calling read each time, its logic is set up for kind of assuming that that's the case. And in my code, that's not actually what's happening. Instead of us calling read each time, we're not calling read each time, and instead what's happening is we have this callback, and this callback is firing and calling attempt parse file with the current buffer of everything that it's read, and it's always, each time it reads, it'll add to the end of that buffer. So it's just like a completely different paradigm as far as how it's doing the reading to iterate through it. And so this logic must not work for the way I've done it. And I'm thinking right here looks like the culprit to me. Probably we're not setting this variable to the right thing. And then because that's not set to the right thing, it means we are copying the wrong data into the wrong spot with this line here. And it also potentially means that that next line there is going to be messed up. And then everything goes haywire because it's also inside of a while loop, and our only breakout condition is the file being the correct size. Well, the length of the data buffer being the correct size. And what we end up with, the problem is we never hit the correct size because we get to be a little bit less than the correct size, and then we add another 512 bytes or something, and then we end up bigger than the correct size, and then it's infinite loop. So realistically, I guess we should have a less than or a greater than equals, so that if data buffer was ever bigger than we were expecting, we would return. That way it would at least break out, but it's not going to be the actual correct contents of the file anyway, we know. So I don't know, maybe it's better, but I'm actually going to set it back for now. All right, I will wrap it up there for now. Thank you, as always, to everyone for watching. As far as I'm aware, I think Scott's back next week, or at the very least, I haven't talked to him about it yet. So for now, I would say the plan is I think Scott's back next week. You know, subject to change always, because I'm obviously not in contact with him right now. So, you know, maybe he is, maybe he's not. I will be back tomorrow morning at the normal time, 10 a.m. Central Time. If you're interested in some more CircuitPython action, that'll be over on my own channel, but I'll put links in the live broadcast chat when I get started. And yeah, thanks again to everyone for watching. Hope you all have a good rest of your Friday night and a good weekend. I will see you all later. Thanks.